Last type of problem that we're going to talk about is how to do the reverse of what we're doing. So if you're given a graph of something that looks like a sine or a cosine wave, we should be able to come up with the correct formula for it. So number 5 says, express the equation for the sine wave shown below in the form a sine bx plus c plus d. Then express the equation for the cosine wave shown below in this form. So actually sine and cosine are the exact same. They're just a horizontal shift away from each other. So one thing I want to point out is this d that we've now added in. So notice we're adding this to the whole function. So this is just like what we've learned before. This is our vertical shift. Okay, so let's talk about the process we use to go from just a graph of a sine curve and then coming up with its formula. So the first thing that I want us to do is to draw one cycle of the original, just so you have something to compare it to. So basically figuring out what the parent function is. Well, we're given that it's sine, so y equals sine of x, and then just drawing out what one cycle looks like. So remember, it's always 0, 1, 0, -1, and 0. So what we want to do is match up the stuff that's on this graph to what we have in our original. And so after just drawing or thinking about what it looks like in your mind, the next step is to find the middle and compare. So notice from the original, the middle of our sine graph is actually our x-axis, but that's not the middle in the shifted one. So what we want to do is create kind of like a quote-unquote new x-axis. So what we want to do is find the middle, so you can just add these numbers and divide by 2, or you can kind of count, well, here's the top, here's the bottom, and kind of go in and match up to see. So it looks like the middle is happening at y equals 2. So we want to match this middle up with this middle over here. Okay, and so now what we want to do is compare what's happening here with what's happening here. So we basically want to figure out what's one cycle, what's going to be our starting point and our ending point. So sine originally starts at 0, 0, so it starts down at the middle. So we want to find the place where our new graph starts at the middle. So here is an option. Also, here is an option. And so remember, the graphs just go on and on. So just choosing one place to start, doesn't matter which one. I'm going to choose this one and call this my starting point. And it's going to match up with this starting point. And then notice we go up, down, and up to the middle. That's where we're going to end. So up, down, and up to the middle. This is where our sine graph will end. So this is one complete cycle. And basically this is everything we need to be able to come up with an equation. All right, so students typically mix this up. So I always like to say we want to find the words first, and then we'll come back and find these letters. And what do I mean by words? Well, these are our definition words. So things like the amplitude, we can look at this graph and see, oh, well, 1, 2, 3 to get to the top, 1, 2, 3 to get to the bottom. The amplitude is 3. I can also figure out my vertical shift, so how much we've shifted up and down. And this is why finding that middle line is so important, right? The middle used to be at y equals 0, but now it's at y equals 2. We've shifted up 2 units, so the vertical shift is 2. All right, I'm now going to go ahead and find the phase shift. So basically this is our new way of saying horizontal shift, so shift left and right. So notice here, if we're talking about horizontally, in the original, the graph starts at the origin, 0, 0. But here in our transform one, it's been shifted over to the right a bit. It's been shifted over to 1/2 to the right. So that's our phase shift. And then finally, the period. So how long is one cycle? Well, we can just count how long from where it starts to end. So I can use these points, 1/2 and 9/2, or I can use these points because this is where it repeats as well, 11/2 and 3/2. All right, so we just want to do one complete cycle. I'll use my starting and end points since I put them there for a reason, but you can always use wherever we repeat again. So I'm going to go with here, so between 4 and 5, that's going to be 9/2, and subtract where we started, 1/2. So the period of our graph is 8. And so it's very tempting to try to use these numbers as our final answer, and that is not correct. All right, so once we find the words, step 4 is to find the letters. So these are our A, B, C, and D, and some of them match up perfectly. For example, our amplitude, that's going to be exactly what A is. Also our vertical shift, we've shifted up 2 units, so D is going to be 2. All right, things get a little trickier with the period and phase shift because we have formulas for those. All right, so remember our period is 4, but remember there's a formula for that, 2π/b. So 2π/b should be the period, which is 4. And so we can use this to solve for b. So I'm going to multiply through by the b, divide the 4. So we got b is π/2. All right, and then finally we need to find C, and we're going to use our phase shift to do that. So phase shift. All right, so our phase shift is 1/2, and remember our formula for phase shift is -c/b. And luckily we just found what b is. So we can multiply both sides by π/2 and then make it negative. So -π/4 is C. Okay, and so then that is everything we need to come up with our equation for sine, right? So sine is y equals, our A is 3, sine of b is π/2, x, that's 2 down there, and then minus π/4, and then plus 2. And this is our sine graph. All right, and so next I am going to show how we can find our cosine formula from the same graph.